Today I want to talk about an introduction to graphs. And to do so, let me start with a simple picture in which a graph, we're trying to capture formally a picture like this. Well, simply dots with lines. And to do so, well, we can take the picture itself, but really what matters in this case is, well, how is that the dots are connected to each other. And why don't I do the following? I'm just going to label them. So I label this as 1, 2, 3, and 4. So I can say that a graph is simply two things: a collection of dots that I'm going to call vertices, and a collection of lines that I'm going to call edges. Well, look, the lines have no direction. What I want to state is that I can go from 1 to 2 and from 2 to 1. So I can do that by introducing an unordered pair. So formally, a graph is the following. A graph G is a tuple where V is a finite set and E is a collection of unordered pairs of elements from V. So in the example that we have here, let's capture it completely. Here I have G as a picture, but I can have G formally. So I can write G as VE, where V is the set 1, 2, 3, 4, according to the labels that I have there. And E, well, the collection of edges which corresponds to these lines. Well, I have a line that joins 1 with 2, so I have my pair 1, 2. I have my line that joins from 2 to 3, so I have my pair 2, 3. I have one that joins 3 with 4, and I have one line that joins 4 with 2. There we go. That is my graph. And now this is formally, and this is informally. Let's see. Uh, is this suited for another representation? Indeed. If we are prescribing labels as integers, just like in this case, we can also introduce what we call the adjacency matrix. In which we state the following. So I introduce the following array: 1, 2, 3, 4, 1, 2, 3, 4. And then on this array that I have here, I will introduce a 1 whenever I see a connection, and I will set a 0 whenever I don't have it. So I don't have a line that joins 1 with 1, so I'll just put a 0. I have a line that joins 1 with 2, so I'll put a 1 here. I don't have a line that joins 1 with 3 nor with 4, so 0, 0. What about 2? Well, I have 1 that joins with 1. I have 1 that joins with 2. No. What about 2 with 3? That one we have. What about 2 with 4? Yeah, we have. What about 3? Well, 3 not with 1, but with 2. Not with 3, but with 4. Now, what about 4? Well, not with 1, 1 with 2, 1 with 3, but not with 4. Now, one of the advantages of this is that the array that we have here, called the matrix, is symmetric, right? If we look at this diagonal made of zeros, we have a mirror image. There are other representations, for example, what we call an